Now, the last video cut off before I was able to explain to you and show you. Now, in part C, they're telling you what if they change the guidelines and now the maximum height that they can reach is 2000 and write the new inequality. So I don't believe we did that. I directly graphed it. So let's go ahead and write the new equation. So your equation now should be less than or equal to 2000. Now there's two ways to solve that, but since they told you to use the discriminant, it means you have to actually show me the work. And you have to basically put it in standard form first. So you need to subtract 2000 from both sides. But it's always good to see it on the calculator to see what to expect. Is it going to pass the guideline? Is it not going to pass? So now the A is going to be negative 16, the B is going to be 336, and the C is going to be negative 1900. So let me go do this with you first, do the math, and then we can graph it to see what's going to happen. So let me go to the main screen, clear that. Okay, now the new B, or the B is going to be the same, it's 336 to the power 2 minus 4 times A, which is negative 16, and then multiplied by C, which is in this case now negative 1900. So let's see, is it gonna pass? So I got a negative number, negative 8,704. Now the number itself does not matter, but what does the negative mean? So since I have the discriminant to be a negative number, then it means that there's no real root. It means that my fireworks will not touch the guideline, so it's below it. So yes, if the new guideline is going to be 2,000 feet, my fireworks would pass the federal requirements. Now to see this and to make sure that you're absolutely right, go to your y equals and put the y1 to be negative 16x squared plus 336x plus 100. As you can see, I put the equation as it is, the main equation for the fireworks. And y2, they gave me the guidelines to be 2000. And I need to fix my window now. Oh, I see what I did in the previous video. That's why I was waiting for the red line to show up, but it didn't, because I need to fix the y maximum to be higher than the guideline for me to be able to see it. So now I push the y maximum more than 2000. I'm going to graph it. So that's the blue line, which is the fireworks. And that's the guideline, the 2000 feet. As you can see, the fireworks did meet the requirement. It did not cross the federal requirements. So that's how you solve a problem like that using the discriminant, and you can always check or use the calculator to check. Now let's move on to the third example. Okay. Again, this is on the practice sheet 456. So that's the third example. A parabolic racetrack can be modeled with the equation. So that's the racetrack. As you can see, it's a quadratic equation. X represents the horizontal distance, and the y represents the vertical distance from the judge's stand. Now, the racehorse got frightened and breaks away from his trainer and runs on a course modeled by this equation. Now, at what point will the horse cross the racetrack? Now, every time they say cross, it means you're looking for an intersection. Now, if you look at the first equation, this is a parabola. If you look at the second equation, that's a linear function. So basically, you're looking for the intersection between the parabola and the line. And you need to find what this intersection is. We're going to use a graphing calculator to be solving. Now, every time you have something like that, let me always reset your calculator so I can fix my window with you. Now, you are lucky, and over here they gave you the window, but you don't really need it. What if you get a problem like that and you need to fix the window? Now, so let me start first of all by saying that the first equation, you put it in y1, and the second equation, you put it in y2. So let's do that. 2x to the second negative or minus 28x plus 200. And in the second equation, I'm going to put y2, which is going to be 16x plus 56. And now, to fix the window, I'm going to disregard this part and I'm going to talk to you how I'm going to figure it out with you. Now look at the intercept. 200 is going to be my y-intercept, okay? So you can start by having a number that's higher than 200. So go to the y maximum. Now remember, that's the y-intercept, and since the a is positive, so this is going to be a parabola that's open downward, okay? So the vertex probably is going to be higher than 200. So I'm going to put, like, let's say 500 for now. Any number that's higher than 200. So you can always go back and fix it. I always like to change my x maximum to be higher than a 10 if the y maximum is this high. So I'm going to put 15 for now. And I'm going to graph it. And remember, you can always go back and forth to fix it. Did I say open downward? It should open upward, as you can see, since the a is positive. There you go. I saw the two graphs and I was able to see the intersection between them. So you do so far. You put the first equation in y1, the second equation in y2, and you try to graph it to see the intersection between the two equations, okay? The two graphs. Now you want the intersection because they want to know when the horse will cross the track. So you go to second trace and you go to number 5, which is intersect. You move the cursor to where the first intersection is at. It doesn't have to be 100% precise as long as you're close to it, and press enter 3 times. Now the first intersection is 18, 344. Write that down. It means the horizontal distance is 18 and the vertical distance is 344. This is what x and y stand for in this problem. Now to find the other point of intersection, you do second trace again and number 5, and you move the cursor to where the other point of intersection is, so the calculator would know that this is the point you're interested in, and press enter 3 times. So now the other point of intersection is 420. Again, this stands for the horizontal distance and this stands for the vertical distance, I think. Let me see. X is horizontal and y is vertical, yeah. Make this bigger a little bit. Okay, now we're ready to write. So at what points? Let's write them down. The first point was 4, 12, and the second point was 18, 344. And since this is a word problem, I don't want you to just give me numbers. I want you to know what you're doing, like to actually know what these numbers stand for. And they want you to write a sentence describing the places the horse crosses the track in relationship to the judge's stand. So if you want to describe the first one, you can say that he's like 4 feet horizontally and 120, I think this is 120 feet vertically when he first crosses the track. And the other time he crosses the track, he's going to be 18 feet horizontally and 344 feet vertically from the judge's stand when he crosses for the second time. Okay, let me check that was 120. Yep, that was 120. So I need to fix this. And that's how you do word problems. I hope that this video helped you understand more the applications for discriminant and quadratic formula. Have a nice day.